talking about prepping for winter. We're all beekeepers here or interested in beekeeping. And if there's anything that I've been learning about bees, it's that it's never too soon to think about the winter, which, I feel like we just came out of winter, but we should already be thinking about it. So let's start out with where we've been before. And this is probably why we're interested in how we overwinter. So let me get my right screen. There we go. I just visited the Bee Informed Partnership this afternoon online just to quick check out their colony management and loss maps and surveys, just to come up with some data, give us a starting point. I don't mean to start out with a negative thing, but this is why it's important for us to know about how we want to overwinter. This is all the survey years reported for Virginia. This is our average backyard beekeeper defined by the Bee Informed Partnership as less than 51 hives, has lost on average around 40% of their hives every year. And so if you've got some hives there, you're going to lose them, and you're going to spend the rest of your spring either trying to make up for it or trying to figure out what's going on. And that's a tough game to keep up with. We're doing slightly better than these commercial numbers and not quite as good as the sideline. And maybe that gets into some of what the different business models are for those. But that's a pretty high number. Did anybody here keep bees before varroa mites? Anybody? Not really seeing anybody pop up in the chat or anything like that.
Okay. I did. Hello.
You did? Great.
In Connecticut.
Oh, in Connecticut. And so I guess that your losses might have been a different kind of story than what we're seeing.
Not at all. They were so healthy, and we lived there 8 years and then moved down to Virginia and strapped the hive on the back of the truck and brought them on down.
That's a great story. I'm getting a great mental image of that. That's nice. Yeah, so before we had this number one pest, it seemed like things were much different when it came to overwintering. We basically just needed to think about not being greedy beekeepers, make sure that we had the opportunity for the bees to have the honey that they needed to overwinter and do their bee thing. So I thought we might look at this from a couple of different angles. And I wanted to just give you a little bit of tidbits in case you want to see some more data that I pulled. This average of less than 40% is from around 34,545 responses. So that's hives total of 6,000 plus responses. So out of that reporting cohort that we've had, and you all know that this is voluntary information that can be submitted, that's where we're coming up with these numbers. It's not something that I have a secret account to log in and see where everybody is. I'm also bad at reporting these numbers myself. Of course, it's my job to also torture my bees for research in some cases. So I've stolen some things from class here. I just kind of want to use this to sprinkle in with some of the other things that I plan on talking about. We know that our honeybees are specifically adapted to be able to overwinter. This is significantly different than what we see in the other members of the Hymenoptera, talking about wasps and other bees. We have solitary bees, we have social bees or somewhat social bees. For example, the bumblebee, they don't overwinter as a colony. They do functionally a lot of the same things, and they do get large in numbers, but they don't have this overlap of generation and the ability to start over in the spring with a full workforce. Instead, we start over with one queen bumblebee, and then she has to lay egg one and start from there to start her colony. Our bees, on the other hand, are always thinking about the winter. They are making sure that their colony is good and strong. They are laying eggs to do so and getting all kinds of resources to feed those larvae, and then visiting flowers, millions of them, to come up with nectar, that then turn that into honey to be able to use that as fuel in the winter. So that whole process is what allows them to be able to do it. So some of that we see changes with the increased lifespan of these bees. I like to call them, if the spring bee is a race car bee, which is what I like to call them in class, then I think of the winter bees as being kind of like the station wagon bee, where they're in it for the long haul. They're going to carry a lot of stuff through, and they are physiologically younger. They have more fat bodies and things like that allow them to deal with thermoregulation and have their immune system be stronger on the end. And so it's a totally different kind of bee. It's not what you would see just cruising out in the flow and doing all kinds of stuff and being very short-lived because they're just going all the time. Instead, these are going to huddle inside and keep each other warm. Because of that, they're going to suspend brood rearing, and this gets into a very temperature-specific situation where we know the difference between rearing brood and not rearing brood ends up changing around the thermoregulation in the hive and changes around what's going on. So we can see early winter when there's no brood, then they might be somewhere around 76 to 80 degrees Fahrenheit. But in the late winter, it's going to be around 93 degrees when they're rearing brood. And that's one of the ways that we know that it takes 21 days to make an adult worker bees, because insects are temperature dependent on their growth and their activity. And these insects can maintain their own temperature. And so they can, like clockwork, crank out adults from there. And then lastly, our bees need to be able to use the bathroom. It makes a big difference. If they can't use the bathroom, then we can see that the stress can build up inside the hive, and we can see some other challenges resulting from there. Everybody with me so far? Microphone still working and everything?
All good.
All right.
We're here.
Great. So we know that these bees are storing away honey. It's really that excess honey left over from the summer. And the good rule of thumb has been typically a 40 to 60 pounds of honey. That'll be enough to get them through. And if you can't get that, you can feed them. And some people make a big deal about feeding bees, but I wouldn't. A lot of people that keep cattle don't, or have cows and cattle, don't make a big deal about feeding them. So I don't think we should think the same at all about us. So we should be taking care of our bees whenever they need it. In the fall, we're feeding a 2-to-1 sugar solution. So they treat it as honey and put it away as honey. They treat it as very sweet nectar and put it away. Right now, or in the spring, you might have been feeding a 1-to-1 solution if you were having the need to feed. And that's more of a stimulative feeding, getting them to get out, have the energy that they need to go out and make some things happen. Whereas this 2-to-1, now we're in an emergency situation and we're getting them to put it away. So that's one thing to keep in mind. If you are doing this feeding, pay attention what frames are open and where they're going to put this away, because that's not what you want to harvest in the next year. So they also need to have pollen. This is probably the one thing that I harp on in my class, because we teach it in the spring when it's nasty and it's cold. It's technically January and it's Blacksburg, so things get kind of cold and hard around here, and there's no flowers whatsoever. So these bees need to be able to tuck away pollen, their protein source, to be able to build larvae and build that new workforce. And so we need to make sure that they have pollen available. It provides this protein in the winter, and you can also feed them pollen supplements. And we'll talk a little bit about that later on. So really in the fall, early fall, we're thinking about colony strength. We want good, strong, healthy colonies going into the fall. And then we want to, in the late fall, early winter, think about individual preparations for each colony in the winter. And for me, these kind of merge together. And so we're going to pick some of these apart. Colony strength, a rule of thumb is somewhere around 30,000 bees. I'm borrowing from the experience of my predecessor, Dr. Fell here, with these numbers, but really they're utilizing it more efficiently. And so I'm going to back that up with some hard science here in a minute. Yeah, and I don't want to get ahead of myself here. So weaker colonies, you want to combine them. I have tried to limp some hives along with support hives, where you technically may change around the thermal inertia so they're less likely to lose heat by having them have a shared wall. The challenge for me is that I don't normally have enough food in there that I can reliably get out to the bee yard, and I have to keep feeding them and feeding them and feeding them. So that has been a weakness to me in overwintering. So wouldn't necessarily recommend that, but don't worry, we will talk about nukes here in a little bit. So recommending colony size, we're talking around 2 full depth hives. Or if you're somebody that uses all mediums, you can go with 3, and somewhere in between there when you're talking about 8 frames. And really, you just want there to be a whole bunch of bees. So 30,000 bees, I would say that's probably close to 16 frames of bees if I had to think about how it breaks out. Good question. And we know that number varies a lot depending on what time of year it is. But yeah, so when I think of a good, strong colony, I think of at least 8 frames out of a 10 frame in use and active with bees. So Yes. Mike? Nope. Okay. So this is the number I want to talk about. This is from an old paper from 1968. And it talks about this relationship between colony size and food consumption. And this is counterintuitive. My bees and beekeeping class, there's no requirements for anybody in there. So I have engineers, I have business majors, I have horticulture majors, I have everybody in there. Just anybody that's interested in bees, just like your beekeeping association. So when I tell them that this is a matter of surface area to volume ratio, I get some interesting looks. Somehow, with having a larger amount of mouths to feed, less honey is consumed. So let's run a little practice here. If we look, we have a colony of 10,000 bees right here. We can see that they would consume about 25 pounds. So let's, for fun, let's go ahead and triple that size. So 30,000 bees would consume around 26 pounds. So we can see that changes significantly. And in between, we can see that it's basically that these colonies, when they're smaller in size, they're not as stable with heat, and it costs them more. And so I would say that the number one diagnosable killing thing of what happens with honeybees overwintering is cold starvation. You may have seen that. You may have seen bees within an inch of honey starving to death, where they're all inside the frames and they've just frozen. And that's not because they couldn't keep themselves warm, or excuse me, that's not because they couldn't, or they didn't have enough honey. It's because at some point their colony size was so small that they couldn't break their cluster. And it's heartbreaking when we run across that. That's definitely not something we want to see. But this is kind of an old thought. So let's fast forward. Let's think about 2019. This is a paper that came out from Dr. Grossinger and others. And this has got kind of a neat thing. What they've done is they've tracked the probability of survival. You and I, as we go out and we buckle up to drive around our town and go to work every day, we're hoping for a survival probability of at least 1. Otherwise, we've got some issues and we're going to collect on insurance if we're not careful. So if we look at this weight, that rule of thumb, 40 to 60 pounds, 44 pounds is right around here. So that's about an 80% chance that these bees will make it. And that's just based on the weight of the hive. So if we are assuming a lot of this weight actually comes from the honey, then that gives us a pretty good number. And so I wanted to show you all this because this is new, and this is a really pretty neat paper. It's called Colony Size Rather Than Geographic Origin of Stocks, Predicts Overwintering Success in Honeybees. And what they did was, and this is in Pennsylvania in this case, they got Southern adapted, Northern adapted, Russian bees, all these other bees, specific hygienics, all these other things. And the one factor that made the difference for the potential success of these colonies was their weight. And so you could have different population sizes and things like that, but if you didn't have the honey, you couldn't make it work. In this case, they wanted to control and have as many bees in there as possible. And so given the right amount of honey and the right number of bees, they can make it. And this sounds like it might be too good to be true, so we're going to have to dive into this a little bit. We can see that the survival rates of colonies somewhere between 10 to 19, so that's less than 44 pounds of weight, were somewhere around a 33% chance of making it, whereas 94% for those that were 30 kilograms plus. So it's a big difference there. It's a neat paper. If you got some time. One of my favorite quotes out of there, and this might be disheartening to some of you, I apologize, is that they talk about the utility of resistant bees, mite-resistant bees. And they said in this case, in the classical botanical sense, resistance isn't really appropriate. They should probably instead be considered tolerance. So that gives us a little something to think about. And maybe you all are picking up a little bit on where I'm going with this. So what about small colonies? What about that late split or that weird swarm that somebody gave you? You can successfully overwinter small colonies. It takes more work because you don't have the workforce that you need to be able to keep things as warm as you possibly can. So then you need to change around the availability of resources to help them energetically spend less energy to try and get access to food and keep themselves warm. So you need to think about feeding in the fall and feeding in the winter. And the winter is the one that gets me, where we'll end up with snow on the ground. We'll end up with just really poor conditions. And some of my, I don't have any flat ground to put my bees on. So that gets to be kind of a challenge. And I'm only willing to almost wreck my truck every other week, not every week. So this feeding thing gets to be kind of a challenge, especially in about February. That's where we run out of food. Early on, you can be thinking about, as soon as they're rearing brood, giving them pollen. Because if you give them those pollen substitutes, they'll be able to go ahead and start to build up their colony numbers, and then they can work on being more efficient and better at keeping themselves warm. But you'll still have to feed, because there will be more mouths to feed, and they won't have the advantage of having all the honey ahead of time. So this is where a site is important. I always think about free heat. It's the number one thing. People say, oh, I'd like to keep my bees in the shade or this or that. I think about how hard the winter is, because we know that bees do it pretty well during the summer, and they can deal with a lot of things. As long as we give them water, they can cool themselves down. So in the winter, the more sunlight they get, the less honey that they're having to burn to get that temperature. And we'll talk about how they heat themselves here in a minute. But think about having that good southern exposure, south, southeast, where they're getting that early sunrise and getting a quick start to it. So if it's going to be a warmer day, then they're getting warmer sooner. That gives them the opportunity to go out and take a cleansing flight, things like that. And then wind protection. We end up with some howling winter winds up here, or excuse me, down here, I guess, in perspective to you all. And it's disheartening when you find an inner cover that's been blown about 40, 50 feet off the top of your hive. So have bricks on things, use straps if you need to. Make sure that your hive stands are good and stable. Have a windbreak. I mean, I've seen bees that are maybe 4 steps off the side of a barn, but it was the only structure around. There were no trees. There was nothing else like that. And they were surrounded by creeks, so they couldn't really get down there on the creek bed, because then they would be dealing with some cool, damp air. So a windbreak is useful, even if it's just a solid privacy fence. I'm working on establishing an apiary up in the Northern Virginia 4-H Center in Front Royal. And they said, hey, you can have at this field. Good luck. Turns out there's a lot of rocks in that field. So I'm using privacy fence to make myself a windbreak, and also to keep 4-Hers from running straight into bees unguided. And that's what I'm going to have to rely on. Now, I am sort of near some trees, but I'm not right up against the windbreak, because I do want to take advantage of that early morning sun that's coming through. So just a little thought there about that. So let's switch gears and talk about what's going on inside the hive. Is everybody with me so far? Seems like
good.
All right, great. I know you said people might
We're
interject. So
here.
given some opportunity for interjection here. I know I can talk rapid fire if I'm not careful. So this is another interesting thing from the Journal of Experimental Biology, where they can use a camera to measure heat. And you might have seen some pictures like this, especially when people were talking about the Japanese honeybee killing and heating up the giant Asian hornet that's coming to you wouldn't see. Similar kind of technology here, where they're using the heat to reflect what's going on, and they can estimate how warm this is. So, sorry. If we look here, if they cut right through the center of a cluster, they can see that it's very, very warm. And so you can see the temperature here on the x-axis. And if you look right here, this is where the queen is, tucked right inside there. So one of the things I had to do is I had to introduce these students in my class to the thought that bees have air conditioning, but it's not central air. Well, it is central air during the summer, but during the winter, the heat is really just around themselves. And they don't want this queen to go into any stress, so they give her the opportunity to stay nice and warm. And then the bees on the outside are going to be a colder temperature. So then they kind of trade places and things like that. It's not like somebody got banished to the outside of the cluster for the whole winter, but they can cycle in and out, in and out. And this is kind of interesting. I don't know how many of you have had the advantage of cracking open a hive in the winter to make sure everybody's there. They'll kind of, if they're cold, they'll give you this porcupine response, where they all stick their abdomens up in the air and they give you the stingers out and kind of hope that you run into it. Well, those are cold bees. But if you poke them one more time, you're going to get a bee in the face. And it's a warm bee from the inside of this cluster who's warm enough to be able to fly. It can come up, and then it can do something like sting. So that's just a quick aside. If you take the temperature of their thorax, which is the part that's the wings and the legs come out of, that's what they're shivering to keep themselves warm, those flight muscles. And so we can see that it's definitely keeping them nice and warm. So this is the cluster surface. They are just keeping themselves above the chill coma, where if they get too cold, they won't be able to basically wake up and survive. So they are using as little energy as possible out here on the outside. But then we see on the inside, they're getting nice and warm, gaining on 90 plus degrees really quick. So I like to show a couple of these things. This is taken after some work that Tom Seeley did, just to touch back on this idea of there not being central air. So if we look here, we can see that in the bottom box, once these bees have moved up a little bit, in the bottom box, we're looking at a -7, so close to 19 degrees Celsius. And then it gets warmer up to 45 degrees. And then right here in the center, they're looking, or right here, they're looking at around 91 degrees. And so actually probably the inside, we're looking at 93 degrees. So just to give you an idea, they're not heating up the whole thing. They're just heating themselves up. And this is where we end up with this challenge. If we lose a larger population of bees throughout the winter, then this cluster has to be tighter and tighter and smaller. So then they are less likely to be able to break that to be able to get access to honey. And that's where we run across things like cold starvation. And then just because everybody loves a good Celsius versus Fahrenheit kind of comparison, I like this little thermometer picture over here. And this kind of gives us some behavioral stuff. So if we look, that chill coma we were talking about, they're estimating around 40 degrees. This is from the Beekeeper's Handbook. We can see that they're not really moving. And then around 40 degrees, excuse me, 50, that they're not rearing and the workers aren't flying. And then around 57, depending on who you read it from, then that really changes a good bit. Well, I'm seeing a question pop in. Is that chamber a set of mediums or deeps? Well, this is from the 70s. I can't say. I would assume it was deeps. I'd have to go and reread the paper on this one. Good question, though. And if you want to chase somebody in their scientific career, I definitely recommend Tom Seeley. He did a bunch of very interesting and elegant work. My students accuse me of having a research crush on him, but it's got some really neat stuff that he's done. So yeah, this is just a nice little thing. And I like this, this thermometer here, just to give us a perspective of what's going on. And so we can see this 93 to 94 degrees. That's where we're looking at that nest temperature. And that's where we see a big change in what has to happen in the colony from the early winter to the late winter. Once they start rearing brood, then it's a totally different ballgame and a totally different burn rate, basically, of honey. So this is just to give us that cold situation we're looking at. You can see these bees are actually spilling out a little bit. So I think in this case, I had an observation pane of glass on top just for my lab students to be able to see. So these are the warmer bees that are coming out here. And that's probably a little bit later in the semester. So I also kind of like some of these old pictures that they have. This is something I dug up from, I think, Bee Source. They were holding this USDA document here, just to give us an idea or a cutaway of what this looks like inside the cluster. So I know it's not the best resolution. I apologize. So can everybody see my mouse, or do I need to change it to a color or something like that?
Anybody? I can see it okay.
See it okay? Oh. Well, now that I've mentioned, I'll just go ahead and try it for a laser pointer for my own edification. I hope you don't mind. So we can see down here at the bottom of the hive where we're talking about A, and these are full depths in this case. We're just looking at empty combs. Here we can see an insulating shell of bees. So these are these outer bees that are not going to be as warm. And then we can see this heat producing center. And in this case, they are very deep inside here, and they're actually inside the combs. And that's how they get that real densely packed situation here. And this can kind of change. Oh, there's pollen and all this other stuff. This can change the density of this with the temperature. So as it's colder, it gets tighter and tighter. And at some point you run out of room. But as it's warmer, it can expand. So we can see an expansion and contraction, expansion and contraction. So if we use sunlight to our advantage, then they can burn less fuel to do an expansion to perhaps go out and get more of the honey from elsewhere in the hive and things like that. And it's more of an advantage for them. So the question is, can we wrap hives hold on to that thought. I'll get right back to you with that. That's a good question. And then I just kind of like these cutaways. I try and describe things differently, and I'm sort of visual, as you might tell, or be able to tell. Let me see here. There we go. Pointer options, automatic. Okay. So I got rid of my fancy laser pointer that's not that fancy. So now somebody wanted to do an undergraduate project and asked if they could take some pictures of my hives. And so I looked it up. I think 13 is close to 65 degrees. And if you look, you can see that the higher concentration of red, the darker the image is, that's actually more heat that we see. So in the inside, we can see that there's a cluster of bees here, even around 65. It's probably not actually a cluster in this case. I would imagine it's more of a, oh, this is probably a nuke here. It's more of it. This is just where the brood is being reared. And so that's why we see that it's warmer. But even in the middle of this time where there's green grass and everything, you can see the heads over here because we needed weed eat, evidently. And yes, I see now it is a nuke. There's not a whole bunch of stuff going on upstairs. So just to give you an idea there, let's look at a full depth, or excuse me, a full 10 frame here. We've got a couple medium depths, and then it looks like I'm feeding up here. And you can see that it's just a much different area of concentration of bees. This is still around 65 degrees, just to give you an idea of what's going on there. So even in the summer, it's not central air, but I do like how you can see a little bit of a vent here. I don't know if you all can see that, but it's almost like the tailings of a dam, to where there's heat leaking out here at the bottom and they're ventilating on this side. And there's a little damp spot, or a cooler spot here, because it doesn't look like there's as many bees ventilating in that area. It's amazing what you can do when you have an expensive camera. Maybe I'll put it on my shopping list. So should we insulate hives? Eleanor, yes, you can wrap hives all you would like. But I would like to ask you about the thermos, or in this case, I think I've got a double-walled bottle over here that somebody gave me one Christmas. You can wrap. If you wrap your hive, it's like putting in hot coffee into a thermos. It will still lose heat. It will just lose it slowly. Well, that's the idea, that they would be less likely to lose heat, or it would slow down the rate at which they lose heat, and they'd be better off. For me, in Virginia, the challenge is it works the other way. If you put in lukewarm, it's not going to get warmer. It's going to get cooler still. Or in this case, if these bees need to get warmer, they're not going to be able to get warmer as quickly. So then if we wrap them, they're going to be as warm as they can keep themselves. If we don't wrap them, then they can use things like sunlight to their advantage, which I think makes a big difference in little bits of them basically being able to go out and use the bathroom during the winter. So let's try it out. The cluster itself provides the insulation. So the insulation slows down temperature changes both directions, changes up and changes down. We are typically thinking about it in the changes down. We want to prevent them from cooling. But the exact opposite happens as well, that we're preventing them from heating up very quickly. And so that could be the difference of them being able to alleviate a little bit of stress here and there. So it can hold in cold temperatures. And then that can end up slowing down their ability to rear brood and a couple other things. So as a general rule of thumb, we do not recommend wrapping hives in Virginia. Some people talk about, well, what if I use felt or roofing felt or something like that? It's thinner. It may allow more heat to come through. It's black. Well, I don't know if you all have been noticing that every now and then we'll end up with like 70 or 80 degrees in February. That'd be a great way to cook a whole hive if you weren't careful. So I wouldn't necessarily recommend that. But if it's in your backyard and that's all you're going to be doing, sure, you could be on top of that. But I don't know if it weighs out. Sorry, did somebody have something they wanted to chime in with?
I wanted to ask if the same would apply to polystyrene hives, that there would be a negative.
So that's a good question. The polystyrene, that's extruded foam, right?
Yeah.
Yes, I would think so. I'm not the what's the plastic ones? Not polyethylene. I can't remember exactly what they are, but yes, I would think that would have a similar effect. Yes, I think they're basically just made out of the same kind of thing that you would have with sheeting insulation on the outside of your house. Same idea, that is preventing those changes or those fluctuations. Now, if we had it to where our winter set in 1 week every single year, then that might be something we want to think about. But instead, it comes and goes, and we end up with these nice little breaks. for our sanity, so we can get outside and go do some things, but also that does give the bees the opportunity to go out and use the bathroom, which might not sound like much, but if you had 6 legs and they were all crossed, it'd be kind of hard to get some other stuff done. And that free heat allows them to shift around their cluster, and that can make a big difference. So how do you want to go about feeding bees? Well, basically go for whatever works for you, except for maybe don't try this Boardman entrance one. And I don't know who Boardman is. It's probably some old white guy, but the challenge here is that is anybody familiar with the Boardman feeder? It's just a mason jar that sits on the outside. It has a couple issues. One of them is this is exposed to external temperatures. So it can get really cold really quick because it's basically losing all its heat to the entire environment above it. And then it doesn't necessarily have a seal. So some of them have seals, some of them don't have seals, and it goes straight into the entrance. So if it's very cold, your bees are up here clustering, you're feeding them, so they're probably weaker, so they're not taking advantage of that heat quite as quick as the hive next door. That hive next door comes in, starts to feed here, and what's to stop them? They're bigger, they're gonna be warmer sooner, they're gonna be able to go out and rob that hive, not necessarily approving that, especially since we know in the age of plastics that we've got all kinds of extra things you can throw in. You can use division board feeders, whichever way you want. I do recommend making sure that you've got something for your bees to be able to climb out there, because as soon as they don't, they'll start to die in there. And then you'll end up with small hive beetle basically doing backstrokes in there. And that's not a fun way to have a spring, by cursing at small hive beetles. You can also use these hive top feeders. The advantage is that you just dump some and go, and you don't really have to interrupt the hive like you would if you were to remove a division board feeder. The challenges are, though, that is quite a bit of surface area. And so you can end up with large rates of evaporation when things do get warmer. And so you can end up with probably some excess moisture. So I found in the freeze thaw period that we end up with in the early spring that these aren't my best friend, because I can end up with a little bit of mildew here and there. So I think in some cases I've had maybe a screen top over that, and that might be an advantage. So one advantage is that you don't have to go as often because you can hold a large volume. But then that's assuming that you have level hives. Most people don't have level hives because they want the rain to drain out. So then you got to kind of wiggle to make this stuff work. An easy thing is to use a pail. So go get a plastic bucket and get yourself a nail that you'd use for the top bar of your frame. Stab it in with a bunch of pliers, or with a pair of pliers into that top to perforate it. Make your 2-to-1 sugar solution in there. Turn it upside down, and it'll create a vacuum lock. And so it won't just spill out. Pro tips: have a very secure lid. You do not want to pull this thing off to check it to make sure that it's not getting a bunch of mold growing inside there or mildew and have it spill all over your cluster. So you want to be careful about how you go about exactly doing these feedings. And in reality, we know that we're bargain hunting. We're looking for what's going to be on sale. We're looking for what works for us. And we're looking for what fits our management needs. How often can we get out to our bee yard to feed them? Do we need to have a larger volume because we can't get out there that often? Things like that. I see questions popped up. First winter with bees: feeding with the top jar feeder and inserting pollen patties. Great. Does the opening in the hive let out too much heat? And is there a temp when you would not open the top, letting the heat out? So John, you're using a top jar feeder. So in this case, what's going on here? Actually, let me go back a slide or two. This one right here is something that's being fed or was recently fed with a top gallon feeder. In this case, I just took my inner cover and put it right here. So then that left the basically the handle that they leave in the middle there, that left that for the bees to be able to get up and get out there. It doesn't leave a whole bunch of escaping heat. And then we're really high tech. We'll go grab 3 sticks of the same size, a little bit bigger than a pencil, so about a little bit bigger than the width of a bee, and we'll make a tripod to hold up this thing to where the bees can get in and out, but there's not a whole bunch of airflow. And then you've got your top on top of that. So this whole box is empty. It's set for the feeder on the inside. And so if we need to replace that, we don't have to break the seal. We can just go and you can thump it, see if it's full or not. And then you can carefully lift up from the lid, flip it back over and swap it out. So we'll commonly take a clean one with us fill it up and put it on, and then take the old one back to the lab with us and scrub it all out and everything. In terms of pollen patties, that's sort of when you see fit. So you don't need to give the bees pollen patties when they're not rearing brood. And so you can wait until they are rearing brood, and you want to wait for a warmer day. When you're doing things like going in and doing inspections and going through and checking on the food and stuff, you want to do it when they have a chance to get out. If the bees are flying at all, then okay, now you can be going in there and checking them out. You don't want to do a full inspection. Basically, our early winter or our late winter, early spring inspections are to make sure that they're alive and make sure that they have the resources they need to stay alive. Afterwards, when they have a nice pattern that we can go and evaluate, then we can think about larger inspections and things like that. So yes, John, you're welcome. And yeah, let's talk about feeding a little bit of pollen right now. So here's a study, this one, 2006, so not too old, just to give you an idea of what a pollen substitute can do. It is a substitute. And as we all know, variety is the spice of life, and that is not what you can find inside of whatever brand pollen patties you're buying. You're basically buying some variation of soy protein. It's a protein source, check. It's got some oils in it to make it smell nice. My students always want to take a bite of it. Every now and then they do. I don't know. They just do stuff like that. But the idea is that there's nothing blooming other than maybe an occasional dandelion, but they want to make brood. So now you don't want them to be pollen limited. You want to give them what they need. Also, if you give them a whole bunch of pollen and you don't have many bees, that's a great place for small hive beetles to lay their eggs. So we had to be kind of careful about that. So you want to give them just enough, especially if you have the chance to go back in there. So think about when we end up with those kind of not freakishly warm, but those warm spells that come and go in the late winter. That's a nice time to be able to get those pollen. So let me quick walk through this, and I'll answer the question that I've got here in the chat. So our control here in this situation where they did not do anything is this circle pattern here. So we can see that in March, they didn't do anything. This is just a normal hive. And we can see that their population grows and grows and grows. Not bad. That bee colony works. We can see here that when they give pollen supplementation, that we can see that they grow at a much higher rate. And by the time April sets in, when we start to see some of our trees really beginning to pop, not just things like maples, they are already stronger, considerably stronger, 10,000 bees stronger. And then if they're to take away some of the pollen, we can see that it has a serious detrimental effect on their ability to rear brood and leaves them 10,000 less bees in this case. So you don't have to do this. You can leave them alone, but there are advantages to doing this. So you give it a try, see if it works for you. One challenge for me is getting them up and running too quick. The worst I ever had was I had this double deep nuke, and I just shoved a bunch of pollen patties in there, and they just ran with it, and it was fantastic. And then March came around and decided it still wanted to be winter, and I couldn't get out one weekend to refill their feeder. So then I come back to an entirely dead, too deep, full, beautiful pattern of bees, and that was heartbreaking, because I'd pushed them too soon. So that's always kind of the thing that keeps me up at night in the late winter, is thinking about how much should I do and how soon should I push them. And really, I try and take a guess at what the weather's going to do or what I think it's done in the past. And it's a guessing game. So what setup do I recommend for feeding a nuke pollen patties? Same as a regular hive. Yeah, so we've got a bunch of 40-pound blocks of pollen patties that somebody bought for some experiments. So I just keep them in the freezer, and I'll thaw some out and let the students, play with them, make them flat. And I think for an experiment, I measured them and saw that it was somewhere around 25 grams or something like that. So 250 grams. So not that much, maybe less than a quarter pound. But anyway, something a little bit smaller in your hand, and you just put it over top of where the brood nest is. If you know that they're already rearing brood, you want to, just like you would in the making a queen situation and trying to make a starter hive, you want to make sure that pollen is right near where it needs to be put to work, put to use. So right over top of that. Often I'll work to maintain my brood nest below, especially in something like a nuke where there's honey above, and they'll kind of get honey bound for a little bit. So you can easily just kind of crack your nuke open and slide this in above, make sure you're not smashing too many bees, and put it back down. And sometimes I'll use wax paper to smooth it out and make it kind of flat. And I'll peel off one side of the wax paper and leave that part down. And then should we be concerned about 2-to-1 sugar syrup freezing? In short, no. In full length, somebody commented to a student that was working with me one time, why would you ever do that? Why would you ever feed sugar syrup? Because a lot of people are fans of candy and fondant and things like that. So I like to think about all these situations kind of in a rational or logical manner. And somebody had a different opinion than me. And then they said, well, why? And so it was presented to me after the fact. So I had the chance to think about it a little bit. For me, when I think of a bee getting access to sugar, I can see a few things. I can see that honey is super concentrated, but if I'm feeding, we're not really talking about honey. If I give them hard sugar, just some people sprinkle granulated sugar over top of a hive. Those bees need to come up with a way to dissolve that. So those bees now need to have water to be able to lick it, to then turn that into a transferable through trophallaxis dissolved sugar solution. So they have to make a sugar solution. So that takes a little bit of effort and definitely a couple temperature limitations. Same thing with the fondant. It's just a cake. Now it might be highly concentrated in terms of sugar, but it's limited in the amount of moisture that it has, so that it requires more work. If we were to use something like this, vacuum locked gallon feeder, then we can see that there is moisture available, but it's not just inundating the hive. So the bees can go up and feed, and they can just immediately transfer and feed their sisters, and everybody can be warm with much less energy spent. So that's why we use it. But this person was kind of personal, and I was kind of concerned with what they thought. So I looked it up. The freezing point of a 2-to-1 sugar solution was somewhere below 12 degrees. So that's really cold. And if that's on top of my hive, that means that my bees are getting somewhere around 12 degrees, not far at all from where they would normally be able to feed, which doesn't make sense. We can see that that's not really how that's going to work. It would take a lot, because the idea is that, you don't want a gallon of sugar water freezing and then thawing on top of your hive, because that thawing, that freezing part makes it expand. You could be cracking your bucket, cracking the lid, and the thawing would just create a drip, and it wouldn't just drive them nuts. It would also chill them. So we definitely don't want to do that. So I'm using plastic. I'm not using glass, and that 2-to-1, it's really thick, and I've not had issues with it freezing. But good question. And thank you all for riding with me on that little thought journey we had. So Catherine has a question. Before winter, should you rearrange frames in the hive or trust the bees to know what to do? I can give you the number one answer in biology, and it depends. You don't want to have a whole bunch of brood up top going into the winter, and then honey just kind of mixed all throughout. You can consolidate. And ideally, that's what we're doing in the fall, is we're helping them figure out what's going on to where they are supered with honey above the brood nest, to where as they are building up, then it's right next door, just like we would see in the natural nest. Do you need to have a full audit? Well, it depends on if these bees are sloppy. And if these bees are sloppy, then you should be thinking about requeening. And you should be thinking about what may have made them sloppy. That's kind of when I'm teaching students about evaluating patterns of queens and laying patterns and things like that. We try not to be too judgy when the conditions are weird, but when the conditions are great, things should be perfect. So if conditions are great and things aren't perfect, then that leads us to believe that there might be some other issues going on that we need to check out. Does that answer your question, Catherine? Sorry, I think the settings you all have are direct messages only to the host, and so I hope I'm not outing everybody in their curiosity. I don't.
Yeah, that does answer my question.
Great.
So I've been concerned about that, to try to get ready. I'm thinking about winter now. So
well, that's good. That's great. And yeah, if it seems disorganized now, yeah, you could go in, you could step in. Now's the time to step in and orient things like it would make sense for them to be oriented. Super above the brood nest, make sure that they've got resources down. You can do things like reverse kind of late in the season. So if you don't think this hive has enough pollen, you could put the young brood way before they get capped down at the entrance. So now when those bees, those foragers are coming through the hive to get up to put food away, they're having to walk through a cloud of pheromone that says, feed me. And it's not saying feed me nectar, it's saying feed me pollen. So you can encourage pollen hoarding by doing things like that, just using the biology of the bee to cue up the foragers to go out and do things like pick up pollen. So that just gives you an idea about how you can manipulate organization. I am always shy to do anything with the brood nest because of our kind of weird springs. I don't want to end up with chilled brood, but I'd say we're long past that, but only a couple of weeks ago, we were in the 40s overnight. So, but ideally, and I know this, my colonies were strong enough that that was not an issue. So yeah, that always leaves me a little bit of hesitancy. Also, when I teach this in the spring and they don't get really, they finish up maybe early May. So we still have some issues we have to be careful with some of the late winter. So I have to get used to when the students leave and I get to do my own beekeeping. Good questions. I hope that was clear enough. And I always worry that people think the biologist answer of it depends is a cop-out, but in reality, it does depend because we know that so many colonies can be different from their neighbors. So that's why it helps to have more than one hive and see the differences, or go out and check out somebody else's hives and see what looks like normal and what looks successful. Great question. So just a quick review before we go down the next path. So every colony needs to have a great queen. We can track all of the successes of the hive to the queen in weather, basically. And then we can also inversely blame everything else on the queen if it's not our fault. So we need to make sure we have a good, healthy queen. We want the colonies to be protected from extremes. We don't want them to get super cold, super quick. We want to make sure that they aren't just going to get inundated with cold, damp air. And then we want to make sure that we are protecting these hives individually. Great. So then every colony needs to have enough honey to get by. And then they need to have a disease and parasite-free, strong population. I'm going to pause there and take a question real quick from Eris. They have a vertical freezer full of honey that the bees made in early spring using sugar water they gave them. What should you do this summer? They usually give them a bucket in the yard, but now they have those frames. They could let them eat their honey stores or keep feeding them sugar honey. So Harris, that's a good question. I would put those on the emergency list. So if you've got something like a nuke that you need to limp along, you could thaw them out first, let them get to room temp before you put them in the hive and help them out that way. But that's simple sugar. I mean, that's just sucrose there if it's made from table sugar. And so it's not going to be as beneficial to them because of that, but also because there are other components of honey that are going to be more healthy for them. So they can put sugar water away and it can still work as technically a fuel source, but it would be similar to us, getting all of our calories just from plain rice. It wouldn't hurt us necessarily the same. We could still technically survive on that, but we'd end up with some, kind of chronic disorders where we wouldn't have some of the other micronutrients that would otherwise be available, especially in some of these other nectars. So I would put that on the emergency list. If you're going to consider having to feed, then yeah, that's a type of food right there. But your bees would benefit more from having access to honey, for sure. So it's that variety of spice life thing. Same thing with the pollen substitute, except for in this case, the pollen substitute, like in that study I showed you, is more of a stimulant thing where we're really increasing that brood just a little bit ahead of time. Whereas when we're talking about feeding for the overwintering for the nectar, we're talking about survivability, getting them to limp along to where they can get strong enough to then go take advantage of that flow. Does that answer your question, Eris? Am I saying your name right? Wrong? Sorry. Yes, no, maybe? Well, so just doing a quick time check. We're just under an hour. And, well, I've got some other things queued up. And I want to see how you all are doing and what you're interested in. You may have noticed that I have been hinting about one or two things about the health of the colony, different than just the other preparations. Has anybody picked up on that?
Yes.
Yes? No? Great.
Yeah.
Would you like to see what I have in store to talk about?
Definitely.
Great. Okay, so let's continue on this theme and let's talk about the other issue. This is the elephant in the room. This is the bane of our existence. So I have had the opportunity to talk about varroa mites. I knew when I interviewed for this job that I was going to be talking about varroa mites. I was going to be talking about small hive beetle. And those are going to be the two biggest pests, two biggest issues we're going to have to deal with. And unfortunately, I was right. And I have kind of not looked forward to being able to talk about this because I know that people have got some very serious, if not hard set opinions about varroas and varroa management. And so I was invited, as I have been a number of times, to Abingdon to talk to their the Mountain Empire Beekeepers Association. And they said, well, we'd like for you to talk for 3 hours on varroa mites. Don't worry, I'm not going to talk for 3 hours about varroa mites, but I had to figure out something different. And so I realized that I had some beekeepers in that audience or in that group that had been keeping bees for decades. So they are dealing with some information or some understanding, maybe from before I ever had the chance to get into bees. And so I wanted to see about presenting them with my new framework that I've been developing as a professional about this. So let's start with the very basics. And I hope that this will go together for you all. Full disclosure, I am borrowing and stealing resources from all over the place. I do give credit where credit is due throughout this presentation here, and you'll see, just like before, where I use citations and things. In this case, if you'd like the sources after the fact, I can send you a file that's got all the links. I think that everything I'm getting ready to use right now is open access, which is fantastic. So, have you all done anything with the Honeybee Health Coalition? Yes, no, maybe, kind of, sort of. Okay, well, let's just quick listen to this and let me make sure that my audio works and give you all an opportunity here. Check this out. Will varroa kill my bees?
Honeybees suffer from a parasite that is their most devastating pest, the varroa mite. This mite is widespread and common. It spreads viruses and will kill most colonies within a year or two if nothing is done. This bee has been fed on by varroa mites. She will never recover and will soon die. If you keep bees and do nothing to manage varroa mites, your bees will die. Hi, I'm Danielle Downey, Executive Director of Project Apis M.
And I'm Mark Dykes, President of the Apiary Inspectors of America. Nearby colonies, even healthy ones, will likely be the next victims of these mites. Controlling varroa mites is part of being a responsible beekeeper. Don't let your bees and then your neighbor's bees suffer and die needlessly.
There are many treatments to control varroa mites, including organic protocols. Consult the Honeybee Health Coalition Tools for Varroa Management Guide, and also these educational videos to learn to monitor and treat your bees for varroa mites.
That's it. That's the end all be all. Really, we just need to check this out. No, I can't tell you enough how much this is a very useful guide, and it's continuously updated, although I think it was last updated 2018. And it's basically a solid handbook, and the Honeybee Health Coalition has other stuff as well. And they're a nonprofit. I'm not getting paid by them or anything like that. So let's move on. So now let's talk a little bit about the distribution of Varroa destructor, which I happen to like Latin names. I think that they can be, if they're done well, they can really describe something. And so this is one of my favorite ones that I hate because it is a destructor. And so it lives up to its name. So we can see that it was over here in Asia on the Apis cerani, and that was its original host. And so we can see that it ended up jumping ship, quite literally in some cases, and moving over to the Americas. And this was likely through queen trade. And so it ended up jumping species from Apis cerani to this new Apis mellifera. And this makes a big difference because they have different brood cycles. So originally, we thought that this was a parasitic brood, and it fed on the blood of the honeybee, the hemolymph, as you all may have heard it, and that it only hitched a ride on adult bees. This is something that we would call phorecy or phoretic, where an animal is traveling on another animal just to get somewhere. That sounds kind of innocent, right? With that understanding, that means that this is not going to impact us during the winter. That means that varroa mites cause no issues in the winter because they're just hitching a ride. They're not feeding on adult bees, and they only feed on the blood. So what's a little vampire every now and then if you know when it's going to attack? Well, thanks to Dr. Samuel Ramsey, as I'm sure you all have had the opportunity to meet with him before. If not, please look him up. He's great. He came up with this great work, and he was able to really drill down through and come up with all the questions that would allow him to make some good, solid conclusions about what the mites do. And he found they feed on the fat body tissue. You may have heard me mention this. That was one of the things that makes our overwintering bees physiologically young. So it's kind of neat. So from there, we see that there are two distinct phases, and I'm borrowing from now Kristen Trainer. I can't remember the first name right now, apologize. Where there's a reproductive phase where this foundress mite goes in with the honeybee as it's being capped and starts to reproduce. Then there's a dispersal phase, which we had previously called phoretic, where the mite is on the back of an adult bee getting to the next place. We say that this is not phoretic. It's not just hitching a ride, because we now know that it is capable of feeding on adult honeybees, capable of feeding on fat bodies. So that's totally different understanding from where we were prior to 2019. So let's look at it. I try and describe this to my students, and I say this would be as though I had a parasite the size of a Frisbee on me. And that really wouldn't be good, especially if I were trying to do the nap time kind of thing that we see going on with metamorphosis and everything. Sorry, let me get a little bit of water here so I don't lose my thought. So this is just re-describing the situation, and we can see that they lay the first eggs about 60 hours after being inside that cell, and then they're laying more every 30 hours. So this is kind of a predictable rate because we know that the brood is being kept at a predictable temperature. The mites develop, and they require 6 to 7 days to complete development. In drones that we know spend longer in the pupal stage, we can see that one mite goes in and then up to 4 come out ready to do it all over again. So when we sample for mites, we are trying to catch those mites that are catching a ride. We are not looking at what could be the 4 mites coming out to take over afterwards. So it's always a different story. So we put together some work. This is a fantastic student, Morgan Roth, who did her master's here with us. She's now working on small hive beetle for her PhD. And she's also a bit of an illustrator. And this is just to kind of show you what it looks like, where here is the mite, the founder's mite. She gets into this cell and hides in the food. It's capped, then it begins to feed. It's smart, it feeds in one place because at some point, this goes through, in its metamorphosis, it goes through this goo-like sac stage. And if it were to feed all over the place, it would just rupture and drown. So that's not the case. So as it lays its egg, the first male comes out. It's a deuteranymph. And then the subsequent eggs will be female. And that will be the source of the genetic material for all of his sisters. And they all feed from the same spot. So then he dies and he gets left behind. And then the female, the mother, the foundress, and her daughters emerge out after the fact. So I told you I like visuals. I like other visuals. This is from Trainer et al. And this is actually about how viruses can get transmitted. But I also like this visual here. So we can see here the life cycle of the bee, where we've got this day 1, egg is laid, 3 days, it's hatching out, and it gets larger and larger and larger, goes through all of its stadia. The mite comes in here, it gets capped. You see, this is the male mite, female mites, and then male mite dies off, and then all the adult mites come out. So really it goes through a whole bunch of stuff going on there. What's also unfortunate is this mite is capable of carrying viruses. So if being a bad vampire wasn't bad enough, it can transmit viruses. So this is a really neat figure. I like all the different things that it explains in here. So if we look, we can see that Varroa is here in this maroon color. And also this is similar to Trophola labs, which is currently what Dr. Samuel Ramsey is working on. It feeds on the mite and it feeds on the adult, and it can pick up a virus and transmit it to the next adult by feeding. So that means if we have one mite and one sick bee going into the winter in our 30,000 bees, if it jumps ship, it can infect the next bee and the next bee and the next bee. Now, we know it's probably not going to be one. Then we can see that in some cases, it can jump in and then infect the larvae. So then you end up with a multiplying number of mites that are then capable of transmitting the virus because it infected this larvae, the pupae, and then it continued on with the virus because the daughter mites ended up picking it up there. So it can get transmitted there. Then if we have hygienic bees and that you end up with bald brood where they're peeling off that capping and they're really trying to get in there and rip stuff out, then we can see some cannibalism is one way for bees to pick up some of these viruses. So then they're going to feed each other and through the adults, it can get transmitted there through trophollaxis. And then the worker bees need to be feeding our larvae to make them be able to complete their life cycle so they can also feed it to the larvae. And it takes something like 6,000 visits, no, over 6,000 visits to one cell for a larvae to go from egg to adult. So think of all the different worker bees that could be involved with one larvae there. Then worst case scenario, we can end up giving it to the queen. And actually, let me see if I have one more. No, okay, I think I pulled that one off. I think there's another route over here that shows up. But if it gets to the queen through something like feeding, then the queen can actually vertically transmit it to where she lays an egg that's already infected. Or the drone could have it and it could be carried over through his sperm and into the ovaries of the queen, and then we can see infections go out from there. So I point all this out, not just to jump and talk about viruses, but this is the other shoe dropping. This is the other bad part of what's going on with Varroa. They are not only feeding and decimating what's going on inside of the actual bee, they are additionally bringing in viruses. We'll talk more about that in a minute. So what are they doing to the brood? They are directly feeding on it, damaging them. They are feeding on the fat bodies. So this is a key, this is a list of what those fat bodies are going to do. They are central to fat and protein storage. It's also central to the immune response of the individual bee. It helps them in thermoregulation and vitellogenesis that help to regulate the behavioral shifts. So we can see in levels that are not synchronous, or excuse me, in levels that have been impacted by Varroa feeding, that we can end up with bees being promoted too soon. So we can end up with a cascade effect. As these bees are going through as an adult, having been fed on before, but their vitellogenins are limited in how they should be responding, then they're more likely to jump up to something like a foraging stage. So if we have adult bees that are dying because they're being fed on, and we end up with these things getting promoted too soon, then we can end up with workers that aren't doing what they should do, and we can end up with individual feeding having large colony level effects. Takeaway, they are stealing nutrients. And then there's this cascade of downstream things that happens because they fed on these bees. So that's bad, unarguably bad. One thing that Dr. Ramsey did was he went and said, where are these mites? How many people have had somebody tell them, and I'm gonna give you some room for anonymity here, had somebody tell them that they don't see the mites, so they must not have a mite problem? Anybody? I've had that. Plenty of people have said, plenty of people who wear corrective lenses like I do tell me that they are not seeing mites, and so it's not a problem. Well, if we look at this here, we would expect to see mites here. This is the stereotypical picture right here on the back, right in the middle of the thorax. That's where that mite is hitching a ride. Well, that happens less than 1% of the time based on all the sampling that Dr. Ramsey did. Instead, we can see this hot spot here, 60.58, right here on the sternite of the abdomen. Does anybody want to guess what organ is behind that hot spot? Those are the fat bodies. So go figure, they're there. And if we're seeing mites here on top and it happens less than 1%, then we might already be in a bad spot. So that's not what we want to see. So then there was some excellent electron microscopy that Dr. Ramsey did where he found these mites and wanted to show exactly where they were. So if we look right here, we can see right underneath this plate, sitting there feeding. And this is what a close-up view looks like. So then they remove that mite to see what was going on inside there. So first, it's not where we expected. Second, it looked like it was feeding. Third, let's take a close-up view and see if it was feeding. Well, here's the hole, and here's where it glued itself in there. So this is the hole that's a close-up here. So that's it. We just threw out everything prior to 2019. Totally different story. It's there. It's feeding in this one spot. We know it's feeding on the adult bees. So what's wrong with this picture? These are my bees. These were my bees. This is basically a dead hive walking in this case. Does anybody see any issues or have an idea of why I would pronounce them dead? Please look at my dirty laundry and the skeletons in the closet here. You can see that I've got hive beetles right here on the open face of a frame. Just while we're looking, I've got mites here. Look at that. If it's less than 1% of the time that you're going to find a mite right here, then I've got a bigger problem. And you zoom in and you can see actually there are more mites here. We've got mite here. I'm trying to remember exactly where they were. Mite here. We've got mites elsewhere. One of them had 2 on it last time I looked. I can't remember, but anyway, we know if it's less than 1% of the time that they're there, that we have a large problem. Consequently, this was September, and I found deformed wing virus in the hive. Deformed wing virus is really only truly symptomatic in around 1% of the adult bees. So if I've got 300 bees and I see one deformed wing virus looking bee, does that mean I have a less than 1% infection? No, it means that there's actually probably closer to like a 99% infection. And it's just so bad that I'm actually able to see what's going on here. So it really changes what's going on around here. Oh, wait. Just to hammer the point home. No, it didn't work. Sorry, I had a pop-up here about visual sampling, but that's okay. Are you all okay with one more quick video? This gets into Dr. Trainer talking about her work in this, for me, hammers home the perspective of how the biology of this mite makes it our worst enemy. So.
Varroa destructor is an obligate parasite of honeybees with no alternative host, so the two have a close interrelationship. Here we represent the theoretical growth of a healthy colony without mite treatments in the Northern Hemisphere. In winter, colonies are typically comprised of all adult winter bees, shown here in dark blue, with very little worker brood, represented in light brown, and low varroa mite populations present on the adult bees. By late winter, the colony substantially increases its brood rearing, and the few surviving varroa mites invade cells for reproduction. As these new bees emerge in early spring, the colony expands rapidly in adult bees, shown in yellow, and brood. The colony commences rearing drone brood, represented in dark brown, which is preferentially invaded by varroa mites. Varroa mites reproduce during the cap brood stage of bee development, so potentially every 12 days in worker brood and every 15 days in drone brood, shown here by the red circles. In contrast, a honeybee colony typically only reproduces via swarming once per year, shown by the yellow circles. After swarm season, the bees stop rearing drones. Now all of the varroa are forced to reproduce in worker brood. If the colony experiences a midsummer nectar dearth, the brood nest contracts and varroa start to appear on adult bees. However, the majority of varroa are still hidden out of sight in the worker brood. It isn't until late summer, when both the bees and brood nest area have contracted, that we start to see varroa mite levels above treatment thresholds on our adult bee population. Late summer is also when colonies are rearing winter brood, represented in light blue. These emerge and become the long-lived winter bees, shown in dark blue. Winter bees have an extra layer of fat body, the organ varroa mites preferentially feed upon. As the colony stops rearing brood in the late fall, varroa are forced to exist on adult bees and have no place to reproduce. The mite population sinks accordingly, and we repeat the entire cycle once again.
So if I were to ask you what the number one thing we can do to prepare for winter would be, what would you tell me?
Mite treatments.
Yeah, you want to make sure that you're taking your mites out of this situation. You don't want them in this equation. You want to have as strong and healthy a hive as possible with the honey that they need to get through it. And then everything else from there is kind of details.
Varroa
I think that we're going to be fighting this battle for a while, but if we can all get on the same page about how serious this issue is, I think we can probably make some headway on knocking down the pressure of some of these viral loads and things like that. And I think that could be where we could go in the futures. If we get on board and we're all make concerted efforts about this and make it a standard thing instead of something like I'm a no treatment kind of person, then I think that can help us all. So that's my soapbox. I also have a whole class worth of soapboxes, but I try and make it fun with videos that are more fun than these, but these are good hard hitting videos. I'm just going to kind of cruise through some of these real quick because I know we're going to get a little short on time. This is just to give you an idea of what that deformed wing virus looks like. For me, if you're seeing this, you're probably actually breaking threshold. Also, I am seeing in this picture what would probably be considered bald brood. So then that's probably what's going to be going on there. So Catherine's asking me, do I have a preferred Varroa treatment? Yes, the one that works at the right time. At the right time. So you can invite me back for a different talk about that. But I can tell you right now, the Honeybee Health Coalition has got fantastic resources. They actually have a whole series of videos about that. That guide will walk you through it. And there's also online, and if you'd like me to, I can pull it up. Hopefully it won't crash on me this time. There's a guide that you can just click through, answer yes or no questions, and it'll tell you which treatment is appropriate at that time. So just to rehash what's going on here, it's a pest and it's a vector. So that makes it two bad things just in one. So that's a good deal. So I'm getting some very specific questions here about treatment stuff. I will hold off on those for right now, and I'll get back to you about that in a minute. So the acquisition phase is the Varroas feeding on the bee tissues, ingesting the pathogens that reside in those tissues. So then mobility is that they're moving freely between other hosts. In this case, we're talking about the individuals. So yeah, then they're transmitting it from there. And during feeding, it introduces the pathogen into the new host. So, excuse me. I think about this as we've done all this effort throughout the fall, throughout the summer, trying to make sure our bees are good and healthy. And then these jerks come in and they're just picking off our bees one by one. They're picking them off by feeding on the very things that help them stay alive. They're picking them off by then getting them sick as well. So then what we thought was going to be a good, strong hive coming out of the winter ends up being smaller and smaller and smaller and smaller. Then we violate a lot of the prep work and a lot of the assumptions that we made about what makes our bees capable of surviving over winter, having a good population that doesn't burn through as much honey. And if it gets smaller and smaller and smaller, and it's hard and it's cold, then there's not the opportunity for them to expand and contract. And then we end up with a cold starvation situation. And that's not fun for anybody. So here's a list of some viruses. I think currently we're somewhere around 18 known honeybee viruses. And yes, Varroa can technically transmit most of those. This gets into some interesting pathology stuff that I'm not going to discuss here. That's certainly not my specialty. I can tell you, though, that things like chronic bee paralysis, or excuse me, acute bee paralysis virus and deformed wing virus have got unique situations with Varroa mites. We can see deformed wing virus occurring in our population, but we don't really see symptoms and issues with it until we also have feeding of the Varroa mite. So then we end up with a synergistic relationship, not additive, not 2 + 2 = 4. In this case, it's like 2 + 2 = 9, where it ends up being much worse because of that. So when do we treat? People say early fall. But I ask in Abingdon, we know that there's a lot of cattlemen up there, and we know that they're dealing a lot with herds. And I say, how many head of cattle is it okay of yours to get sick if you know you can do something to prevent it? Does anybody have any idea how many is an acceptable number to get sick if you can prevent it? 0. You're not going to do that to a cow. Please don't do that to your bees. If you have the chance to stop them early. I think that train of thought has already left the station if we let them get sick. So we want to be careful with that. We want to pay attention. So we need to monitor. We need to know if we have a problem. So we monitor, monitor, monitor. And then the rest comes down to what works for the right situation. So I'll tell you, I commonly use things like formic acid because in my case, the formic acid can kill the mites in the cappings or behind the cappings. So I'm not just killing the mites that are on the bees, I'm killing the mites that are on the larvae. That to me is a no-brainer. I really want to stop that mite in its tracks. There are temperature limitations. I often use this in the spring. As soon as I break threshold, I know that my spring temps are being kind of low for me in my case, so I can keep it below that 90 degrees and I'm less likely to end up with an overdose, essentially, of it hypervolatilizing early on. So that's one treatment. Then I need to find the next treatment. And this is exactly where I am right now. I know that I've probably got to get back out and do my next checks. And I had a couple hives that ran still above threshold or at threshold after treatment. So it just didn't work. And I think in one case, it was a really big hive. So following the label, it didn't exactly do all the job they needed to do. So I need to figure out what to do next. Now I'm limited in my resources because the beekeeping is just one part of my job. It's all full-time job, but I guess there's like 3 or 4 full-time jobs I have together here. So I don't necessarily have a place where I could take all of my honey off and treat my bees for 42 days at a time. So that means my list of recommendations for my own personal use is going to be limited by what I can have with honey supers on. So last year, in the middle of the pandemic and everything else going on, I broke threshold again. So I was on my second treatment. So it was time for me to rotate because I don't want to keep hitting them with the same hammer because at some point they're going to be able to duck that hammer, especially because we know about how the resistance works in organisms like this. That one resistant mite going in and 4 resistant mites coming out is not a good game to play. So I ended up picking up Hop Guard 2 because that was what was available to me. And I used it by the label, but I sort of missed what it was really gunning for. They wanted the recommendation was to use it when it was in the dormant period where they weren't rearing brood because it's not capable of penetrating the cappings, which means that there were going to be more reproductive mites that were going to be able to make it out and do something about it. So it helped me. It worked out. There was one apiary because of supplies I couldn't get to, I couldn't treat. And so that apiary I knew was still high. And I was able to get in before Christmas and do an oxalic acid vaporization. That's the first one I've done because it scared the bejesus out of me because it is a highly caustic, corrosive acid that you are then volatilizing into the air. And I have been trained to apply pesticides. So I'm familiar with pesticide safety, routes of exposure, and safety equipment. So I got fully geared up. I had my organic organic acid and vapor cartridges on my full face fit respirator. I had on my full 14 mil gloves. I had on everything else I needed and about 3 cameras because it was the middle of the pandemic. So I had, GoPro here and another camera here recording all this stuff. And it was fine, but I was my farthest apiary out. That's why I hadn't gotten to it yet. And because of that, some other things happened. So I showed this group in Abingdon my blooper reel, and it was, I had to go through all this work. I had to go out and get a power inverter. I had to keep my truck running the whole time just to be able to run this thing. And it was cold because we're in the dormant period because it's cold. So it took a while for it to get up to actual temperature to volatilize. So then I put it in there and then all of a sudden, poof, a cloud of very dangerous vapor comes out because I had a screen bottom board still on one of my hives. And so it wasted the treatment. It was not a full treatment, not a full dose. But luckily for me and my family, I was fully protected with all of the appropriate personal protective equipment. And had I not been, that was a very dangerous situation for me to be in. So people talk a lot about this treatment versus that treatment. I'm a trained entomologist. And so I have been it's been hammered into me to think about managing against resistance. So if The classic example is aphids on a plant. If you go out and spray one type of chemical on aphids on a plant and you kill 90% of those aphids, you have technically significantly reduced the impact that those aphids are having on the plant. Aphids, however, are what people may, in layman's terms, say are born pregnant, where they're capable of laying live aphids. So that 10 aphids that didn't get killed by that one chemical, if there was something about them that made them resistant to it, they can basically poop out more baby aphids that can go and do it. And they grow very fast, and then you end up with a large population. In fact, if we want to study aphids in one of the crop systems with which I am most familiar, cucurbits, which is plants in the cucumber family, in case you're wondering, Mike, things like pumpkins and squash and stuff like that, we can spray pyrethroid insecticides, and we know that it will flare aphids. It will kill off the natural enemies that would keep them in check, and it will make sure that only those resistant ones are really going, and then they explode. So we do not want anything like that to happen with our varroa mites. They are already the bane of our existence. We do not want to do anything to make them more difficult. So please don't use the same treatment back to back, period. You always want to rotate what's going on. And so you'll hear people talk about modes of action. That's how something works. It's not that you can't use a fumigant more than once. You can use a fumigant, but it needs to be a different active ingredient. So that's why we talk about rotations and rotations of chemistries and things like that. And again, that Honeybee Health Coalition guide is fantastic because it walks through all the pros and cons. And then it tells you exactly what's legal in the United States, also in Canada. And then it tells you the rates of success that people have had from the Be Informed Partnership loss data. And so it says people who've used this have lost hives. It basically shows like the percentage of impact. So that's a fantastic way to do it. And that's what I go to. So when I was dealing with temperature highs and I knew I couldn't use Formic again, I sat there on the back of my truck flipping through this, figuring out what I was going to be able to use next. And then I tried to get it, and COVID happened and all these weird things for shipping. And I finally got it and was able to treat 2 out of my 3 apiaries. So I want to quick say thank you, but then I can field some more questions. And this is our little pumpkin that was upstairs right now. She's in bed by now. Here's my email. It's keepbees@vt.edu. Because we've been virtual and in person and all this other stuff, I get a whole bunch of emails. I apologize if it takes me a while to get back to you. If you haven't heard from me, just chime back in and I'll try and get back to you. Also, we've been doing some other work. I talked about how good Morgan was. We have extension publications like that first thing that I share with you all about the spotted lanternfly. We do things like these pest management guides. And in each one of these sections, this will probably be the most appropriate for you all, unless many of you are in crop production. This is what you would use if you had some pest problems in your own home. And I write the little introductory section that says how not to kill bees. And we basically start out with, don't spray bees on the flower. Don't spray plants when they're flowering. And then these are the lists of insecticides based on the data that we can get access to that say, they're going to be highly toxic for bees. I'm always working to revamp these. I have some ideas about how to revamp it again, but it's sort of on the technical side with dealing with risk issues and stuff like that. Other types of publications, we get into, Morgan was doing a whole bunch of work with varroa mites and varroa mite resistance. It's actually something that's under review right now. And I said, this is going to be 9 pages long. Nobody's going to read it. How about we break it into 3 useful sections? So one is varroa mite biology and feeding damage. Another one is varroa mite sampling methods. How do you know you have the problem? And the other one is varroa mite management methods. These are not recommendations. These just highlight what is available out there. So if you don't know where to start, this could be a useful place to start. It's also free to download. These are all available at pubs.ext.vt.edu. And there's a section under there for beekeeping. And then now she switched gears and is working with a small hive beetle. And she also wrote a small fact sheet on that. And then here's that website I was telling you right there, pubs.ext.vt.edu. And then you saw me reference this earlier. This is an open access publication here in the Journal of Integrated Pest Management. And it is the super long version of all the details about the varroa mite. And it's a full pest profile of the varroa mite. So that's also free to download. I think within a month of us publishing that, we had something like 4,500 people sharing it all over the place and stuff like that. Hey, thanks, Mike. I appreciate it.
Thank you very much. That was fantastic. Any other questions before we kick off here?
I know I shared a lot there, but thank you for the opportunity to share it. Hopefully you were able to get something out of it. And if you need to learn more about the varroa mite stuff, the Honeybee Health Coalition, just spend some time on their website. They've also got some best management practices and things like that they're working on. So it's all good and free, and a whole bunch of people are involved in that. And it's peer reviewed. So it's peer reviewed science, not what you heard down at the hardware store.
All right. Thanks again. We'll probably be looking for you next year too.
Okay. Well, thank you. I go where I'm invited. So thank you very much.
Thanks so much.
You all have a great evening.
You too.